Hey everyone, thank you for being here. We are going to be talking about in our episode club today Star Trek IV, The Voyage Home, the science of Star Trek IV. Just to kick things off, I want to thank you all for being here. I'd like to remind you that if you're here on Twitch, hit the follow button and think about subscribing to help me meet my goals this month. If you're watching on YouTube, please hit the like button and you can subscribe for notifications on when new videos come out, which really helps me bring you this content. And there's also a post of links in the description below, so feel free to check it out. But yeah, thank you. This is going to be so fun. Time travel is happening. I was worried that there might not be enough content in Star Trek IV, and that was a lie. There's plenty of content. Yes, indeed. It's just such a good movie, and my patrons are awesome for voting for this, because I'm super down to talk about my favorite Star Trek film of all time. And I'm happy to see you here. And yes, so diving right in, I think the first thing that we want to talk about is this probe that shows up. So I've got a few kind of highlights that I want to hit. We're going to talk about the probe and the image that they're sending out. Then I'm going to talk about the time travel itself, which is going to be fun. We'll talk a little bit about whales. Not a biologist, not a whale biologist, but fun anecdotes for that. We're also going to talk about crystals and using nuclear fission to recrystallize what we discover were dilithium crystals. And then the science behind storing and transporting whales, which I got a lot into today, and transparent aluminum and the science behind that. So that's a thing that we're going to be talking about. All right, so kicking things off, right? Picking up right after Star Trek 3, Search for Spock, and Spock's memories all bluey, and he keeps, calling Kirk Jim, or calling Kirk Admiral, and he's like, no, it's Jim. And it's adorable. I'm going to fan a lot out of this movie. I may get distracted from science side of things and just talk about how much I love this movie. But hey, Brad. And yeah, so essentially what happens is our intrepid crew have a Klingon ship that they've renamed the HMS Bounty because they've broken rules and they now feel like epic rule breakers. So they felt HMS Bounty would be an appropriate one. And so they they take this ship. And simultaneously, as they started getting it up and running and interfacing, there were some fun sort of throwaway lines where they were basically like, oh, we need a cloaking device. The cloaking device would be good. That we have to interface the guidance system is functional to interface with a Federation computer. And fun fact that I learned yesterday is when Spock is doing his retraining thing that we've seen multiple times before, but the person who wrote this said that they put in a Star Wars Easter egg because yesterday was May the 4th be with you. And it's true that he asked the question, and I caught it today. He asked the question, about this founder of Vulcan philosophy, and the answer is to plan a Hoth, and that was supposed to be a little anagram of Planet Hoth. So that's fun and appropriate for the time of year. But anyway, this probe shows up and it looks weird. It's like a cigar. I know, we're all just one and the same. But it looks like this cigar, and it's got this sphere that's coming out, and it's radiating this sound. Oh, Star Trek 4. You might be my favorite Star Trek movie, but your use of sound in space is fluid at best. Fluid was a very good choice of word for me there. Because in order to hear sound waves, you need a medium to travel through. And electromagnetic waves can be picked up and traveled through space. They don't need a medium. These get confused a lot because electromagnetic waves, low frequency electromagnetic waves, are radio waves. We listen to sound on radios, but radios are picking up radio waves and then translating them into sound. I know it's confusing, and it's okay that it doesn't make a ton of sense, so you are forgiven for that. But they really play fast and loose with this. And I try to be really forgiving, right? Because science fiction is fun, and we want to get excited about it, and we want to have all these fun stories that come out of it. So usually I'm kind of like, well, okay, if they're picking up sound, then really what they're doing is they're picking up electromagnetic signals and then they translate them into sound, which is something that we can do. You may have heard like people find sound in space that they translate. But they're really just picking up electromagnetic waves and then saying like, okay, they're at this frequency. Now let's imagine that that frequency was a sound wave and play it as if it was a sound wave, and then you can hear it. We do the same thing with gravitational waves, actually, is that gravitational waves, they have nothing to do with light or sound or anything, but they are these waves that like travel through space, through the medium of space-time. Hey, Mikhail. And they, you can translate these signals to sound waves, because you just take that frequency and then you like put it in your computer and you're like treat it as sound, and then you hear it. And with the sound waves, you can like translate the sound of like black holes colliding, which is objectively awesome. So why wouldn't you do that? And I had that as my ringtone for a long time, was colliding, this translated sound of colliding black holes. But so most of the time in science fiction, when they're playing fast and loose with sound versus electromagnetic waves in space, I kind of give them a pass, because I'm like, well, you could maybe be translating the electromagnetic waves into a audible frequency. They play fast and loose with that here. It's not at all what they're doing, because they're like, all right, let's take this sound that is somehow radiating through space out from this probe that's like bombarding Earth. It's some like narrow band frequency because it's tearing through the oceans in like a straight line. So it's like a super narrow band. It's just pummeling through space. It's causing like massive cloud cover, and bad things are happening. And essentially they're like, this is bad. And Uhura tries because they're like, oh, it's being directed at the ocean. And so they're like, well, account for what this would sound like through the medium of water, which is great if it's sound waves. But this probe is in space, and it's there's no way it could be sending sound waves, but they're not going to go anywhere. They're just, your little speakers would be pumping out and they wouldn't be hitting any air particles, and so they just wouldn't travel at all. So when they translate these sound waves into traveling through a water medium, if you were to shine light, electromagnetic waves through a water medium, you would get refraction, but it wouldn't sound different. It's getting way too much in the detail. I appreciate it. We're here to lovingly look at science, and like I said, it's my favorite Star Trek movie, so we're gonna give it a lot of a pass. But that's the biggest science failing in this movie, and they kind of get away with it because the story is so solid that you're super there for it. Like, you're on board. That you're like, yeah, obviously they're sending out this signal and it's screwing up the atmosphere and they're trying to communicate with whales. Duh. So the weird ball that hovered below the cigar, that's just gonna be what it is. Yeah, because it basically like comes out and they're starting to like emit this radiation. I just think that that's how they. So first of all, you have to find some way to have it like hover there. And we can give that a lot of a pass, right? Because you could say like, well, we have shields, we have some sort of shield technology, and that it's exactly that. It's an antenna, like it's an emitting antenna is kind of how I view it. And that it's able to like hang there and hover in the same way that we have shield technology would be like holding it there. But I kind of saw it as an antenna. It's gonna come up with a lot of lines. I mean, they do eventually, right? When we see it fly off, they've retracted their ball into the cigar. taken off from there. But they're essentially, they're sending out these waves that we just have to, they're waves that when you, whatever they are, sound different in water that would be able to communicate with whales. And from a storyline, again, there's no way around it to say that, that it's wrong. It's wrong the way they talk about it. Just because of that, like that translation to medium in space. Yeah, exactly. But okay, so going on with that probe thing, since we can't help ourselves. It is funny because that interstellar object, Oumuamua, when it passed through our star system a few years ago, it was like weird and cigar shaped, and it was like tumbling through space, and it looked like this. So everyone was like, "Oh, it's aliens!" And there were epic Star Trek 4 jokes that came out of Oumuamua, but it's not aliens. And we didn't see any suspended balls trying to communicate with humpback whales here on Earth. But yeah, the biggest sort of science fail, as it were, and I hate admitting when we can't science ourselves out of this, is the fact that we're translating it into sound and then translating it through the medium of the ocean, which just kind of doesn't work. Hey, yeah. So we are definitely going to be talking about the mass of the whales and the space that they have. Because, yeah, Klingon fighters, you're looking at like a 20-person crew, maybe 30 max. And they got those dimensions just there. Billy said, it's funny the name of the sounds like the sound of the probe, Oumuamua, because that's what it's doing. It's wah, wah, wah. You get it. You know what I mean. But that is Hawaiian language for, I think, passerby or something, visitor. And that's where that name came from, which is awesome. It's really cool. But not the sound that was coming out of this alien probe. So, we got that out of the way. They realize that it's trying to speak to whales, and we want to go find them. And apparently whales go extinct in the 21st century, so go humanity. And so they need to go back to they need to go back to the 20th century to get these whales, because that was when this was filmed. It is what it is. We love it. It's just the best movie. But the funny thing with time travel in the original series, right, is they treat it like it's super commonplace. They are like, oh, well, let's just make our calculations for time travel. And this holds up because they did the first instance of time travel in the original series was Assignment Earth. And they basically did exactly this. Like, they just slingshot around and they travel through time. And they're like, hey, what's up? And then in Tomorrow is Yesterday as well, another original series episode, they slingshot themselves around basically a black hole. And black holes were like barely in the scientific literature at the time. They just talk about a high gravitational void in space. It's a black hole. But black holes were coined like the same year that episode came out. That's just one of my favorite Star Trek facts ever. But all the original series have no ramifications like with time travel. They're like, all right, well, we'll just go travel through time and we'll follow the rules and then we'll turn around and come home. And we'll do these calculations. Okay. They talk about the parameters that they need to, because remember, they're on a Klingon ship here as well. So Spock, who's still struggling with his memory, is basically like, all right, we're trying to figure out how to engage the computer, which is fun, but perfect for, the time that this was made. And the variables, he says, we need to figure out the availability of fuel, the mass of the vessel through the time continuum, and the location of whales. So the time continuum is just space-time. We've got to figure out what space coordinates we're going to, which is fine. How much fuel they have to get there, that's essentially this gravitational slingshot. So the gravitational slingshot and how that works in time travel, we're going to get into right now. So as we travel through space here in our pre-Cochrane science, it's my term for the real world, because I don't like saying real world versus Star Trek world, because Star Trek is a big part of our world. But the pre-Cochrane science, we travel through our solar system using gravitational slingshots all the time. Behind my camera, behind my desk, is a poster called the Cosmic Exploration. To read it, Cosmic Exploration. And it essentially tracks all of the paths that spacecraft that we have sent into our solar system. And you see it does all of these loops and stuff. And so gravitational slingshots are a way to transfer momentum and to change your speed and direction. Very hard to calculate. Essentially the way it works is it is like a slingshot. It's a good way to think about it. Or to think of, like, if you had a ball at the end of a string and you kind of fling it and it goes off, like shot put, is essentially what you're doing. And what you're doing is you're transferring momentum to it, and then it flies off in a different direction at a greater speed. Now, there is an action-reaction there, that it doesn't necessarily just you're not getting energy from nothing. But when you're using an object as big as a planet, that transfer of momentum is negligible on the orbit of the planet or the star. So it doesn't change its trajectory in any noticeable way. Technically it is. Technically it is transferring momentum, because that speed and that energy has to come from somewhere. But the mass ratios are such that it doesn't have an impact. We're not then flinging Jupiter off in another direction. Tiny spacecraft, big planet. So we use this all the time. It's a great way to adjust speed, direction when you're traveling through the solar system and you are trying to hit these small targets. When it comes to time travel in Star Trek, a little bit different. They're using that same concept, that we have a gravitational slingshot. You approach the sun, so a big source of gravity, like the source of gravity in our solar system. You approach it. As you're approaching it, you go into warp, and then you come out in a different time. They've never explained it beyond that. I've tried to headcanon it a little bit, because I can. And what the way we can think about it is, all right, if you're going to do a gravitational slingshot around the sun, fine, party on, that we've done that. But if you're going into warp as you're doing it, then you're starting to wrap space and time around your ship, as you're already experiencing some distortion from the gravitational well. And Muhammad makes a good point that it's going in both directions, which I can't necessarily fix. Because going back in time, right, we can sort of make it work, because we have this gravitational slingshot. We're going into warp, so we're building a bubble of space-time around your ship, and we're doing it when we're deep in a gravity well. Because when you're using a slingshot, you're essentially going into a gravity well, going around and getting flung out the other side. And because of gravitational time dilation that we've seen in Interstellar and we've seen in other science fiction stories, when you're deeper in a gravity well, you experience time slower than you do on the outside. Now, it's not going to fling you back in time, but it just slows down your time. But if we're building warp bubbles as we do that, then maybe we're just creating so much of a cacophony of time and space that it doesn't quite make it work. And how you can then do it in the future direction. I mean, so I said, like, this isn't the first time that original series has done this. They did it in Assignment Earth. They did it in Tomorrow's Yesterday. And in all of those stories, they're like, all right, we're going to use this gravitational slingshot. We're going to go back in time. And then the story ends. And we're back in the future. So it fixed it somehow. And we have our same calculations. So it works. But it's fun. And and in terms of what you see with creepy heads coming out of the soup of space-time, I love it. I love it. But it is a fun way to think about time travel. So we can't go too wrong there. So that's kind of how we do the time travel around a star. The cool thing is that the ship does start to like break as they're doing it because they're getting to such high warp. And this is, Star Trek also has had varied rules when it comes to warp factor 1, 2, 3. It's essentially, the premise is still the same, that you increase your speed, then you build another bubble that's going to exponentially increase your speed, you build another bubble. But in terms of like where those limits are, we've had in the original series, they'll throw out like warp factor 25. But in this one, they do seem to like have established this limit of 10. And it might be because of this. I haven't done the research. I don't know how much they've talked about that before. But, you have Sulu going warp factor 1, 2, 3, and all the way up. And then they get to like 9.8 and then they make it around. So, yeah, it's definitely not as messy as that. But they were so close to future evolving into lizard people. But one thing I like is that as they are approaching the sun and the ship does start to... First you had Uhura's screen sort of shatters, and then you do actually see cracks form in the ship. You can't think about the fact that they are accelerating towards a deep gravitational well, and so the front of the ship does technically have slightly more gravity than the back of the ship, and we're in warp. So again, you have all of these strains of space-time on this ship that it's not unreasonable that it would be falling apart. But then they make it. And they do talk about it needing to reach the breakaway speed, which is effectively your escape velocity in order to actually get away from the sun and travel back in time. So we managed to do it. They get to Earth. And they date the Earth based on the pollution content, which I always find funny and interesting, but fascinating because it's kind of like carbon dating, but with humanity's presence, and that's not unreasonable. I think for that pollution content is pretty proportional to the types of energy that we're using and how much travel we're doing. Thank you. And so that's not unreasonable to actually use the pollution content to date something, because as our use of fuel changes, our economy, our industries, everything, you're going to have decades with changes in that we probably can't necessarily see because we're so close to it right now. But I don't think that's unreasonable for hundreds of years in the future. Now, they do correctly say, they're in the late 80s at this point, so we need to cloak to avoid space sensors. That's true. There were sensors in space in the 1980s that you would want to cloak yourself from. So they manage it. They find whales, and they are picking up the whale song from space. Once again, I love you, Star Trek 4, but once again, there's no way. If you're in space, you are not going to be picking up sound signals that are emanating from the ocean because there's no medium. You would get it up through the atmosphere, through probably pretty good part of the atmosphere, if you were able to filter it out somehow. But that's hard to do. So, and even then they're well above the atmosphere. It's so thin up there, there's no way that they're getting any sort of compression wave that they would be able to pick up. So when Uhura's like, oh, I'm picking up a whale song coming from California, there's no way. The way that they could do it, though, is to identify heat signatures. That is a way that they could do it. It would be hard and, again, very messy, especially because they're picking up heat signatures of massive mammals that are underwater in a highly populated area. But it's fine. It gave us a good excuse to go visit San Francisco in the late 80s, and I have zero problem with that whatsoever. Now, before they all go their ways to try to find these whales, Scotty points out that the time travel has drained their Klingon crystals. And, right, yeah, exactly, the cetacean navigators. So, we're going to come back to that too. That's in my notes for sure. So the Klingon crystals that Scotty said that they drained, he was like, the time travel drained the Klingon crystals. And of course, like, since watching Discovery season 2, I was like, oh, could we make that time crystals? It's not. He immediately says the dilithium. It's just dilithium crystals that have been strained by this by their time travel, and they're starting to run out. So essentially they're using however they're utilizing the dilithium crystals is breaking up the crystallization, and they're basically harnessing the energy from those dilithium crystals in order to do all of this, which isn't unreasonable, right? So they're going to have to find some way to recrystallize the dilithium. And they're in the 80s. So, and even that, he's like, we haven't even figured that out in our time, how to do this. But we can try to do something here. And so Spock says, well, we might be able to get a good source of energy here in the 20th century because they're using nuclear fission reactors that we have since stopped using because of the toxic side effects. But we can collect the high energy photons to stimulate crystalline restructure. Sure. I guess what they're saying is they're basically going to use the energy from the nuclear fission in order to bring these molecules back together, which is a little bit iffy in the best sense. But, the way that they're talking about it is fair. They correctly say fission versus fusion, and they throw that out as well. Yeah, exactly. And, we love playing with its own canon because it's like a game for us to to try to track and figure it out ourselves. But, so when you talk about nuclear fission versus fusion reactors are the ones that we use, that have been used on nuclear submarines, that are continued to be used. And essentially what you're doing is you have massive atoms that are fairly unstable isotopes, if you remember that from chemistry. Sorry if I'm bringing back memories that you had since buried. But you have these unstable isotopes that are breaking apart, and you can kind of force them to break apart by firing high energy particles at them, which are usually neutrons that we fire. And then when they break apart, you get a whole bunch of energy being released in that process. You get alpha particles, you get beta particles, and you get gamma particles. And alpha particles are essentially ionized helium-ish. They're just 2 protons and 2 neutrons, and they're heavy, and they're easily to be blocked. They are very dangerous, but they're easy to block. They don't travel. You can block them essentially with paper or cloth from traveling. Beta particles are high energy electrons that are firing out. Those require a little bit more buffer to block them. And then the last one is gamma particles, which are gamma radiation. That's high energy photons. So when we were talking about electromagnetic radiation, low energy is radio waves. That has no problem with us. Gamma radiation is the highest. Gamma ray radiation is the highest one. That is that does come off of nuclear vessels in Alameda at the Enterprise aircraft carrier. See, it all comes back together. So we love it. And it's fabulous. And so they go to collect this. It is my favorite. It can't not be one of your favorite scenes to have Chekhov shouting with a Russian accent to find nuclear vessels in Alameda. And we've talked about this episode on this chat before, but the Star Trek Futurama episode where no fan has gone before, when Fry meets Chekhov and he's like, say nuclear vessels. Nuclear vessels. Is amazing. It's just the greatest, and we love it so much. Yeah, to a cop and just shouting it in the middle of the street. And just their whole interaction as they're sitting there and trying not to be conspicuous. And, he's like, Kirk's like, break up, guys. You look weird. You look weird. They all just kind of wander off. I told you I love this movie. I love this movie so much. So the cool thing about it, too, is when they do get to the Enterprise, and they are trying to collect these gamma particles. They are just holding this thing up to the wall and slowly collecting them, which is fair because gamma ray radiation, gamma particles do penetrate, a lot can block them, but those thick lead walls, you do get a lot of gamma radiation through that. That's why if you work at a particle accelerator or in a facility that has any of this, you do have to wear radiation badges to actually track how much you're being exposed to, because you can block some of it, but not all of it. And so them like hunched up against the side trying to collect these gamma rays is absolutely what it is. Now, they're collecting gamma rays. They're essentially collecting light. They're collecting photons. How they would be able to do that is another thing. But we can kind of get around that by just thinking about converting energy, right? Even when we talk about nuclear vessels, I try to work that in as much as I can. Even when we talk about nuclear fission, all you're doing is you're transferring all of that high energy to heat water, is most nuclear power. So you're just transferring that into steam energy, essentially. That heat has to come from somewhere. Or like we were talking about the gravitational slingshot, that you don't get energy for free. And so the energy that we're getting is this energy from the nuclear fission, which is then heating up water, which is then converted to steam, which is then used as a power source. So we can carry that analogy on to what they're doing here by collecting the photons. They can have something that, absorbs this high energy radiation and then stores it like a battery. Sure. There's no reason to get picky about that because it's pretty solid, and they held on to that pretty well. And the reason, in case I didn't make that clear, that we're using the gamma ray particles is because I think it's Scotty or Spock specifically says we need to collect the high energy photons. Yeah, it's Spock who says it, to simulate the crystalline restructure. So he specifically says high energy photons, which are gamma particles from nuclear fission. So solid. We'll give them that. Now let's get on to the cetaceans, because a few of you have mentioned this, that you were talking about the cetacean ops. Oh, that's awesome. First of all, I love ambient noise. Second of all, I love ambient noise from spaceships. And, Phrase, I'm so glad. I'm so happy you're here, because this is 100% what we're here to do. So the cetacean ops that a few of you have mentioned that have popped up recently, thanks to Erin as well for pointing that out in Twitter, I think like yesterday or something, that in the TNG technical manual, they have a cetacean ops, and it is mentioned once in TNG in yesterday's Enterprise, which is a fun episode in itself. But as I was digging more into this, apparently the subtitles on most of the streaming services, I think they said Netflix and Amazon, and the DVDs, actually translate it to station ops. So they've kind of retconned it out a little bit, even though they're saying cetacean ops. They did change the subtitles to be station ops, but boo. The idea behind the cetacean ops is, so cetaceans, this is like my limited biology knowledge. Oh, that's cool. I'll check that out. I'll check out that channel for sure. But cetaceans are basically whales, dolphins, and porpoises, and they have this. That's my knowledge. That's it. I will say though too that there is documented use of military training cetaceans for spying purposes, which even she brings up in Star Trek 4, that she's like, "You're not from the government. You're not going to train my whales to go retrieve bombs or something, are you?" And if you remember, it was a couple years ago that I think in Norway, some fishermen discovered like this wayward whale that had a camera attached to it that they thought came from the Russians. Just weird and funny. But yeah, it's been speculated since the 80s, and I'm, all that research I know has been, some of it, like, people have talked about that's the thing, because they're smart. and they travel in the ocean and are fairly nondescript. So it's not the worst idea for spying. It's just not the most ethical thing for spying. So, but the Cetacean Institute in Star Trek 4, it is the same logo and the same layout. It's the Monterey Bay Aquarium. So if you've ever been or wanted to go, once all of this lifts, you should go check it out and just get a picture. I think a couple people posted pictures of the Monterey Bay Aquarium because it's the same, which is awesome. And the last thing I wanted to mention about whales, and this is diverting a little bit from Star Trek talk, but I have to give a shout out to Eric Spana. Him and I gave a physics and biology of Star Wars panel a few years ago at DragonCon. And one of the things he was trying to figure out was the ability for vegetation on Tatooine to sustain creatures like banthas, because banthas are the big elephant things, and there's like no vegetation or very many creatures on Tatooine. And he discovered that there is a species of krill, which is what humpback whales eat, that lives in the sand. So you can think about the fact that bantha fodder is actually just sand krill, which I love. I just can't not, because it's one of my favorite things that he dug up to be able to actually put some science into Star Wars, and I love it so much. And Star Wars has been on our mind a little recently. I'm still not emotionally over the Clone Wars, but that's for another discussion. So, I loved it. I should say it that way, but I'm still not over that. So, let's go on then to talking about transparent aluminum and storing whales, since we're talking about cetacean ops and how you can actually have it in here. Because I think the cetacean ops that they brought into the TNG world was inspired by the visual of having this, like, essentially aquarium. There's so many good parts in this. But having this aquarium in a ship, and that you can use the cetaceans for navigation, for some form of navigation. And that is possible, like I said, with the military and everything been researched. And the fact that they put that in a starship, I think is awesome. But digging into the physics of it a little bit. Now, it was mentioned earlier at the beginning of the stream that it's really funny that they put this massive aquarium in a Klingon ship. Because I forget this when it's been a while between watching, that they're not on the Enterprise. They're not on a Federation ship. They are on a Klingon ship. They are on a Klingon warbird. And those hold like 20-ish crew, maybe 30. And it's a small ship. And so they're in the bowels of it. And they're like, okay, well, it's about 60 feet. Well, that's good, because humpback whales are about 60 feet long. I did double check all this, but I'm sure that was exactly the thought process in the writing. It was like, how long are humpback whales? They're 60 feet. Okay, the storage bay is 60 feet long. And then they say it's 60 feet by 10 feet. They don't give the third dimension. But they say 60 feet by 10 feet, and then they say it needs to hold 18,000 cubic feet of water. So from that, I mean, we can calculate. We're all trying to remember elementary math these days. 18,000 cubic feet, divide out 60, divide out 10, you're left with 30 feet. So it's a 60 by 10 by 30, which is very convenient because whales are 60 by 10 by 10 to 15. So we can set two whales perfectly side by side in this storage tank with no stress whatsoever at the fact that they literally can't move. but it's fine. Now, yeah, I mean, we have to just fan a little bit about the brilliance of the Scotty Hello Computer, which is even funnier that I could go talk to my Alexa and have it respond to what I have it programmed to respond to and have it calculate things for me, but probably not to pull up schematics for transparent aluminum. And so when this was made, there was no such thing as transparent aluminum. Scotty gave him the molecular specs for it, basically as a trade to get some free plexiglass, which I love. And get free plexiglass, but then, you know, be like, well, or here's your thing, and if you can make this, I'll give it to you if you can make it for me. And he uses the keyboard in a really bashy way. And I also read that the visuals are like of a Mac, but they definitely had to use an IBM because of the refresh rate and the processing for filming it. So we have a whole hybrid mess of computers that are there that he's using and speaking into a mouse and frantically, bizarrely typing. I mean, but like a lot of people typed at computers. It's just such a good scene. And I also love just the idea that, you know, McCoy is immediately like, dude, bro, your timeline, they haven't invented it yet. And he's like, do you know who invented transparent aluminum? Could be this guy. And McCoy's like, all right, I buy it. They're just, all I'll say is they're so lucky Spock wasn't on that with them, because he would have shut that down so fast. And these guys just made this deal that violated a lot of rules in time travel to be able to get away with it. But even though transparent aluminum didn't exist in the 80s, it does technically exist now. It was invented in around 2009, and various sources, you can find lots of things, because obviously a lot of scientists said, I wanted to invent transparent aluminum so I can close the timeline on Star Trek 4. And I have zero doubt that that's what some of the people who researched figuring out transparent aluminum, that was their mindset. But the most common one is called ALON, which stands for aluminum oxynitrate, which is a ceramic that is transparent to 80% of the electromagnetic scale between infrared through visual through ultraviolet. So even Predator wouldn't be able to see, wouldn't see the transparent, it would be transparent to Predator. Predator sees in the infrared. This is still transparent in the infrared. I hope that made sense. Anyway, how much it actually translates to being able to store, to be thick enough to store the cubic feet of 18,000 cubic feet of water, to be determined, because they made it up themselves. But I love the time travel idea, just because I still, like I said earlier, I try not to dismiss Star Trek as like not real life, and for a lot of us, you know, it's embedded in our own lives and everything. But I do love the idea that the Star Trek crew traveling back to the 80s put that nugget in our brains in the 80s to make something called transparent aluminum, which I just love. Like, we got to give it credit for that. And it's fabulous. Now, when they get back up there, they say they have to recalculate their time travel to get back to where they're supposed to be, to account for 400 tons, including the water. I did the math. He is not named Nichols. I'm so sorry. And he's from Oxford. So this guy could have gone and changed his name, because maybe he figured it out. But it would have been pretty cool. But we did the math to figure out what 18,000 cubic feet of water plus... I just realized I did the math wrong on this. Because he says 18,000 cubic feet of water, but you don't have as much water because you have it displaced by the two whales. So 2 whales weigh 66,000 pounds each. So I have to subtract that from mine. So it might actually... I still don't think that's going to get us down to 400. But I think... but I think it's pretty close. I think I can do it. We're gonna real time this because we can. Let me see. That would be about 119. All right, we're gonna convert this from weighted math. All right, so we have 119. Yep. Pounds. Nope, it's still 540. So, yeah, so it's still 500 some tons and not the 400 that they claim it to be, but we're in the order of magnitude, and I'm an astrophysicist, so for me, as long as the times 10 to the thing works, I'm good with it. And it is a lot because they thanks. Because they did that's a ton. You forget how much water actually weighs. And yeah, Kirk was surprised at the number when he asked Scotty, because he said it's 400 tons. That's a lot. And even here, we're getting about 500 tons of 18,000 cubic feet of water, minus the poundage of the whales. You're still looking at hundreds of tons. So it's a lot. And that would drastically affect the mass of your ship, especially when you're on a tiny Klingon ship. Now, if someone, I don't want to calculate that. I don't want to look it up live because it'll be too distracting for me. But if someone happens to know the mass of a Klingon warbird, feel free to throw it in here so we can figure out how much that mass ratio is. But yeah, the escape velocity, because the other thing too, it's not so much the escape velocity to get off of Earth, because I think the Klingon ship is capable of doing that. But it's more the, remember they said when they get around the sun to travel through time, they need to reach their breakaway speed. So they have to recalculate what their breakaway speed needs to be. And we're going to use that as like the time escape velocity in order to get out. Thank you. 30,000 metric tons. So we have that's a lot. So it's a significant percentage, right? You're looking at like what, 2%? You're adding 2% of the mass to a Klingon warbird. That's going to screw up your incredibly precise time travel calculations real fast. But thankfully, Spock is starting to get his brain and he's chilling out a little bit. And thank you. I love you all so much. This is fabulous. Yeah. Oh, just Klingon warbirds. Fitting whales into Klingon warbirds. And as Andrew mentioned earlier, they would not be able to move or breathe or anything. They are stuck in there together, which is just really funny. So those were the kind of the big science points that we hit. We had the probe, right, that flew through, and it basically looks like Oumuamua that came through, and and yeah, Spock can correct the timing vocally. All right, so this fractions of seconds. I love that point actually, because everything else is like precisely collected, and then he's like, I'm just gonna have to guess. And that he's able to say like now, and that you're at least looking at your error, your order of magnitude error has to be like half a second at that point, which is pretty big for precise time travel that you're trying to do. But space is big and weird, and so maybe it works. But yeah, the whole now is funny. So we had this probe, Oumuamua. Biggest science fail, which we have to let it go just because the movie's brilliant, so we'll give them a freebie, is the sound of the being translated through water and into space. So we'll give them a pass on that because the movie's phenomenal and they have so many good lines that they make up for it. That's going to be our metric, right? Excellent dialogue gives you X amount of free science points. The time travel in TOS, in terms of like the ability to do it, TOS as a whole treats it as a standard capability that they have, and it's not weird to do as much as it is later in Star Trek series. They're using a gravitational slingshot to do it, so they're going to go to warp. While I'm recapping this, feel free to throw your favorite moments, because we still have like a few minutes here. So feel free to throw your favorite moments in so we can fan out about it together. Because I tried to focus on the science, but I will talk about this all day because I love this movie. We talked about the cetaceans being used for direction, navigation, and spying. And we talked about the Klingon dilithium crystals that you need. All right, we'll talk about McCoy. The nuclear fission particles, the fact that we got, so good science there, talking about the high energy photons, using them to recrystallize dilithium. We can't say we know for sure how dilithium works, so that's okay-ish. Storing the whales and using transparent aluminum didn't exist in the 80s, but transparent aluminum does exist now. It's technically a ceramic, but it uses primarily aluminum, and it is transparent for most of the visual range, which we love. So, mentioning... All right. We got Dr. McCoy at the hospital. Awesome scene. I love how much he hates modern medicine. Like, he just rages when this woman is like, oh, I'm on dialysis. And he's like, what? Have a pill. You'll feel better. And I love it. It's fabulous that he does that. That he's just, raging at all the doctors and getting in their face and yelling at them about how primitive their medicine is. It's peak McCoy. And I love it. Yeah, truly. It's so good. And they save him. They save Chekhov. So Brad mentioned the Dr. McCoy at the hospital. Billy mentioned the use of language in here. The double dumbass on you, which you can't help but say. And I love to, even like, my partner came up while I was watching the movie, and it was right when they get back to the ship, and like Spock, who's now kind of, his personality's bending out a little bit. I think, what is it? Kirk says like, to your stations, and he responds with like, to hell I will, or damned if I will, or something like that. Like, he just throws out these swear words now randomly. I'm sure some of you may know, some of you may not know, but the punk kid, the jukebox kid, that was played by Kirk Thatcher, who was a big Star Trek fan. The guy, the punk with the jukebox, he convinced Leonard Nimoy to let him play this character, and he's like, no, you're not going to recognize me. Like, I can do the mohawk. This was my jam. I want to be in this. He also provided, I think he may have been, in fact, now that I'm thinking about it, he may have been the one that mentioned the Tiplana Hoth thing, because he did write or he at least vocalized the computer that Spock is interacting with when he's like getting his memory back together, going through all of their math stuff. I tried to pull some of them out. They had like the this was my favorite one. Adjust the sine wave of the magnetic envelope such that anti-neutrons can pass and not anti-gravitons. I kind of like that. That was fun. Oh, that's a really good question. So the question is, when the bird of prey is cloaked as it approaches the whaling ship, also a great scene, would a cloaked ship mask the sound of the engines that it didn't when it landed late at night in San Francisco Park? So that's a really good question, actually. Let's kind of, keep the good moments coming, because it's just such a great movie. But so this goes back to the sound in space thing. Right? We've talked a little bit about science behind cloaked ships and cloaked devices. But essentially what you're trying to do is you're trying to mask the electromagnetic signature of a ship, because sound in space doesn't matter. So if your ship is, like, the engine is giving off noise in space, that's not going to resonate. There's no medium for that resonant to hit. That even if your hull is, like, humming, right? On the inside, you would hear it because it's bouncing off the walls and you have air inside the ship. But outside, you wouldn't necessarily need to cloak sound, because you're already cloaked from sound due to it being a vacuum. But when you're in an atmosphere, I think that's possible. That if you're zipping around in a cloaked ship in the atmosphere, I think it's possible that the technology doesn't account for the sound of the engines going off. But, Andrew, that's actually a really good point. That's probably a better point, actually, that not so much that they wouldn't matter, they wouldn't care about it, but you would be pushing out air in the same way you'd be pushing out water on the ocean as it's landing. So, going to warp from inside an atmosphere, not recommended. We've seen it played a little bit. I think various Star Trek series have done it. Again, TOS is playing fast and loose with the rules. They, like, threw down guidelines and then later series built rules on top of those, which we're okay with. But in terms of going to warp within an atmosphere, essentially the biggest thing is you're not worried so much about the atmosphere, because physics within your warp bubble is still going to be fine. What you would be concerned about is the distortion of the space-time in a gravitational well close to a planet with people. So you'd have to have a really tiny localized warp field to be able to even consider getting away with that. And settling 30,000 tons on the ground would make more, it does depress the grass, right? It's great. They're like, no, there's too many planets around. And, you're welcome, Mikhail. I'm glad you were able to stop by. No, none of this nitpicking is supposed to diminish the love of the franchise. This is all meant as fun. And I hope that's coming across, because it is supposed to be meant as fun. And it's like, when I come at this with with a science brain and both from a consulting standpoint, but also from a teaching standpoint, it's teaching moments, right? If we ask, well, can you go to warp in an atmosphere? Okay, well, what does it mean to go to warp? What does that do to space-time around it? Billy, just quick with those quotes. I love it. If we play our cards right, we may be able to find out when those whales were released. How will playing cards help? I love to. I think probably one of my favorite lines too is oft overlooked one is when they're all standing, like I said, when they're all congregated there, and Kirk's like, you look like a cadet review. They all pass away, pass through each other and everything. Another sort of fun trivia fact that some of you might know is that when they pass the Chinese restaurant with the yellow wall that has that Yellow Pages ad, there was supposed to be dialogue in there that was Sulu's ancestors, and then it got cut out of the story, but that was technically supposed to be his family, because he says, oh, my family's from San Francisco, obviously generations previous, but that was supposed to be part of it. That's awesome, Andrew. Yeah, I love it. It's just, that's the thing, it fills us all with such love and this sort of community that we can talk about just a beloved, fun, weird movie and extract little nuggets of science out of it. And mostly just fan about how great the movie is. And honestly, even rewatching it, it's I could just watch it again because the dialogue is so tight. That's how I often, when we talk about sound in space and the greatest violators of that, you usually think about, one, massive explosions, because that's usually the first thing that you think of. But then we talk about okay, well, maybe there's some shows that have violated it or things like that. I rarely remember how bad Star Trek IV violates the sound in space thing, just because it's such a good movie and it's such a good story. And the fact that they were able to do this. And I will say, man, they kill me here, because all the time travel, all of us who have stayed up, and, Andrew, like you mentioned, being able to stay up and watch Star Trek, it's it reminded me of Doctor Who when they get to bring the scientist with them. I don't have her name written down. You learn, if this is your first time watching my stuff, I'm terrible with names. This is why I take notes. I write them down, because I can't remember anything. If I hear trivia noises, trivia questions, I just hear white noise. But she gets to travel back to the future with them. How I want to do that. That was all of our fantasies. How much is such that same Doctor Who fantasy of just getting picked up in the TARDIS. This is getting picked up by Kirk, which is a different kind of fantasy. Not one I would necessarily subscribe to, but getting picked up by the crew of the Enterprise and being able to travel to the future to join the Federation and become a science officer. Please. That's why most of us got into science, was so we could become science officers here. Oh, yeah, the distress calls. I love that. Such a good line. Awesome. All right, so we are up at the hour. I really appreciate you all hanging out. I hope you had fun talking about this. I did want to make one quick announcement that a couple quick announcements. If you are a patron, which if you're not, there are links below if you're interested. I realize things are weird right now, so it's no problem. But you are able to suggest what you want us to talk about during these and vote on them. So the voting for next week is going to go up tonight. And then I am also in the process. I had some great feedback from people about converting these to podcasts. So I'm going to start working on that this week. So these are going to be released in podcast form, because if you're watching, live is one thing, but if you're trying to catch up with it on YouTube, which the link is also below if you are watching this on Twitch, you can find it later if you missed parts on YouTube. But I will release these as podcasts as well. You won't get to see the expressions or the necessarily the chats, but it's another way to listen to it. Don't even worry about it, Andrew. There's no obligation whatsoever. I'm happy to do this for people. I love being able to take part and share and geek out. So just closing out, thank you so much for watching and being here. If you're here on Twitch, you can follow for more content at no cost or anything. See when we're online next. We do Astronomy Club on Fridays. We do a Star Trek brunch on Sunday mornings where we just kind of free discuss with one of my friends who's watching Star Trek for the first time and take part in live discussions with that. Very little science. It's just fans of Star Trek talking. And then I do these, and then I also stream in between. And I started doing watch parties that we started today, so that was fun. Now, if you are an Amazon Prime member here on Twitch, you can subscribe for free. You have to do that once a month. But if you are interested, you are more than welcome to do that too. And if you're watching this after the fact on YouTube, don't forget to like and subscribe, which does help me to keep doing this and bringing content your way. So thank you all again. Links are below. I love you all. This was really fun. Have a good rest of your evening. Stand up, stretch, have a glass of water, live long and prosper. Until next time, everyone. Bye. Thanks.